Okay, so in the Unit 3, Chapter 5 review, it says, in a standard normal distribution, find the area that lies between 0 and 0.37. So we want to set up a picture to help us solve. 0 is always in the middle, and this is the area that we're finding, that shaded region. In your calculators, we will do normal CDF. We want to make sure that our stat wizard is turned off to be able to enter it in this format. Okay, so for normal CDF, we hit second and distribution. Normal CDF is that second option. We type in 0, 0.37, close our parentheses. We get 0.1443086988. Remember, area or probability under our curve, we always round to 4 decimal places. In B, we're looking at between negative 1.56 and 0. So again, we do our normal CDF. In our calculator, it's negative 0.56 to 0. And in our normal CDF, we type in negative 1.56, this time, to 0. We round to 4 decimal places, we get 0.4406. The next one, between negative 1.06 and 1.29, we're typing in normal CDF, negative 1.06, comma, 1.29. Okay, so negative 1.26, negative 1.06, comma, 1.29. We got 0.7569022783, which is 0.7569 to 4 decimal places. D is another between, but they're both on the same side. What's helpful about a picture here is that we know we're definitely shading less than half of our curve. So if we come up with something greater than 50%, then we know that we did something incorrectly. Okay, so we definitely want to use our pictures, 1, to help us set things up in our calculator correctly, and 2, to check to make sure that our answer in the end makes sense. So we got 0.0581918. So to 4 decimal places, it's 0.0582. E says to the right of z equals 0.45. So in this case, we don't know where we stopped shading at the right, because normal CDF, remember, we start at the left, we go all the way to the right. Technically, it should be to infinity, but again, we can use 10 because we know that it's very unlikely that a data entry is beyond 3 standard deviations of the mean. So if we go to at least 10, we know that we've covered quite a bit of ground from underneath our curve here. So to 4 decimal places, we get 0.3264. Now the next one is all the way to the left. So we're shading to the left of negative 1.34. At the left here, we don't know where we started. Technically, it's negative infinity, but negative 10 will be enough to cover our ground underneath our curve. And we get 0.0901. Okay, the only other type of problem that you're going to see possibly from this set would be, I'm going to actually write it at the top of the page here. Something like below z equals negative 1.32, or above z equals 2.01. So if it's something like this, we're shading to the left and we're shading to the right. Okay, we have two different setups here. We could do normal CDF, -10 to -1.32, and then plus normal CDF 2.01 to 10. Or we know that the entire curve adds up to be 1. So we can actually take away from 1 what we did not shade, and then we'll be left with what we did shade. In this second method, either one, we're going to get the same solution, but the second one at least just requires a little bit less entry or typing into the calculator. And here we get 0.1156. Okay. All right, the last one on this page says, in a normal distribution, find the z-score that cuts off the bottom 40%. So we start shading from the bottom. We don't quite make it halfway, because halfway would be 50%. We have the bottom 40%. Anytime we know area under the curve, we can find the z-score by using the inverse norm. But one thing that's very important to remember about inverse norm is that when you use it in the calculator, whatever number you enter, the calculator sees the bottom of the curve shaded. Well, we shaded the bottom of the curve, so all we have to do is enter in the percentage. We can't type in 40 though, because then the calculator is going to kick back an error. Now our z-scores, we always round to 2 decimal places. So for this one, we're going to put -0.25 as our final answer.